It's a triple first for Sellafield. The first time we've ever moved this type of radioactive waste. The first time we've used this new shielded waste container. The first ever radioactive waste going into a new store. These operators will be able to say they were there when it first happened. Perhaps their children or grandchildren will be doing a similar job in years to come, when box number 1 going to store number 1 is a distant memory. To help them tell their story for generations to come, we need to go back to the beginning. The waste they can be proud of moving to a safer place is a zeolite skip. There were more than 200 of them placed underwater over 40 years ago as a temporary solution to manage corroded fuel in the pond.
Zeolites, in essence, they're like giant sponges. They suck up all the activity prior to then discharging the water within the pond. So that's why we had zeolites, and they were in operational use from around the 1970s, mid-70s to around about 1980s. There's 237 zeolite skips. That represents a population of around about just over 1,000 skips that we have within the pond. So round figures around a quarter of the inventory that we have left within the pond are zeolite skips.
So removing the skips would allow you access to other areas for sludge retrievals, as in like you're hoovering sludge and you're getting rid of that. So it's a bit of a double effort really, because you're by removing the zeolite skips, allowing access to sludge retrieval. That's also highly radioactive waste. It's positive. It's positive, just creating more space in the pond to get rid of the stuff.
The analogy I would perhaps use is that what we're trying to do is to tidy a big room. And if you can imagine a children's bedroom where it's full of toys all scattered on the floor, it's really hard to clean up in that way. So what we're trying to do is to make it more of a tidy room, if you like. And the benefit that gives us is that we can then access the high hazard material that we've still got in the pond to be able to clean that out, get it into an orderly fashion.
The zeolite skips follow the same route out of the pond as the other solid waste and corroded fuel that we've been moving to safer storage for nearly a decade. We've reverse engineered the equipment that used to bring fuel into the pond to get waste out.
So the export facility was originally designed to import inventory into the pond. It was never designed with the mindset of taking inventory out of the pond. So it's been a challenge to reverse the process when then that wasn't the original design intent.
It's a relatively simple process of moving the skip onto an underwater bogie, bringing it up a ramp into an export cell where it's put into the box, lidded, checked, and then brought out to be transported to its new home. The waste container where the skips will be stored is called a self-shielded box. This is no ordinary dustbin. It's a highly engineered shielded container designed to keep its hazardous contents safely stored for many years.
A self-shielded box is a ductile cast iron container that we're going to use to store zeolite material from the pond. It is made up of a main body and a lid. It maintains solid and liquid containment. The filters in the box lid clean any discharges that come from the inventory, and also they allow the exchange of gas so that there's not a build-up of hydrogen in the top of the box.
Manufacturing the self-shielded boxes has been a massive project of its own.
So the boxes are manufactured at a company called Goodwin International in Stoke, and they're quite challenging to make. Ductile cast iron is quite a difficult material to work with. They take approximately 3 to 4 months to manufacture. They're cast in a mould, and then it's poured. It's done in one pour, and then obviously it's left in the mould for quite a number of weeks to cool before they take the mould off, and then the machine any excess and then they go through the painting process, and then obviously all the seals and the filters are put in the lid and everything. That's the final assembly. They also undergo rigorous quality checks before they're released to us, just to make sure that they fulfil those key functional requirements that we need.
Thanks to how robust these 29-tonne boxes are, and thanks to their shielding, it means we can be relatively light touch on their temporary home. The Interim storage facility's walls are nowhere near as thick as some of our stores on the Sellafield site. The inner walls of the vault do provide extra shielding and protection with lead fragments woven through the thick concrete, but this shielding should never actually be needed as the boxes do the job. The store is based on an existing design already used elsewhere in the Nuclear Decommissioning Authority's sites in the UK and has been built to keep costs down. The slope of its roof allows water to run off into drains without any gutters to maintain. It only needs people working there when new packages are being brought in or routine checks are being done on the packages inside.
The interim storage facility has been designed as a suitable storage environment for the boxes. So it's got a ventilation system that minimises any moisture in the air, any dust and any sort of corrosive agents or salts that could be in the environment within the store. And it's also a quite highly regulated temperature control that's on the store to maintain the condition of the boxes. And the boxes also undergo condition monitoring and inspection periodically to ensure that the inventory is in the same condition that we put it in the box, and it's retrievable. The process ports on the lid of the self-shielded box will be used to put an endoscope camera in to assess the condition of the zeolite skip, and that will be done periodically.
The plan is to store the zeolite skips in here for up to 10 years before moving them to the box encapsulation plant, a new facility still being built where they can be removed from the self-shielded boxes and undergo further treatment and conditioning before being disposed of.
The box is playing a real integral part for us in terms of our high hazard risk reduction journey. So initially they will store the zeolite skips, but in parallel we've also been looking at opportunities to be able to also take our fuel and our fuel bearing material to be stored also in the boxes. Again, that plays an incredibly important part both in terms of risk and hazard reduction. The key element for us therefore is that we have resilience in our way of taking out fuel. We already have an established fuel route and we've used that previously over the last 5 years to take some of the fuel out from the facility. The added benefits that we get though from a box is that we have a reduction in single point failures, so we'll have an extra route to be able to take the fuel out. And we also are planning an extended period of time in which that fuel can stay in a box for anything up to around 50 years, subject to condition monitoring and inspection. And with a further opportunity to be able in the future, with minimal conditioning, to actually be the final product that could be put into its final resting place, with its location being in the geological disposal facility.
Having the right people in place to do the work is always an ongoing priority.
Throughout the active commissioning phase, we've worked closely as an integrated team to make sure that we can hand over the procedure to the new operators, maintainers. We've worked really closely to undertake the training to make sure that when we step away as a commissioning and pre-ops department, that we can leave the guys in a good place for sustained operations.
So there's experienced operators like myself running with it, and then that information would then get passed down to other operators.
Anyone who knows the nuclear industry will know that doing anything big for the first time takes years of planning and preparation.
So really regulated industry, you know, we know we work in a complex environment, especially in legacy ponds. You know, as part of that, we like to do internal assurance reviews, and we do that through our nuclear independent oversight team and the hazardous activity readiness review. That allows us to hold a mirror up to ourselves and really confirm our readiness to proceed. This is in line with what we do with our regulators, who we've been working with for a number of years, who do their own reviews, their own internal assurance, constant queries, which we've answered.
For those working on the project, this first export is a huge moment to be proud of.
So we're a close-knit team, we all look out for one each other, and all the individuals are trained to a high standard to work in the high hazard areas. Working on a legacy facility presents many issues, from equipment breakdown, obsolescent parts, historic information not being readily available when we're trying to instill a new process within a legacy facility.
So this job was challenging because of the emergent risks and issues that have cropped up along the way. It's really clear that we wouldn't have got to this position without the hard work and dedication of all the teams involved to get us to the position where we can now say that we've got a Zeolite in a self-shielded box.
Worked for Celifor for 18 years, 11 of those in the ponds. I've seen sludge exports and fuel, empty skips, and now it's going to be zeolites. That's got to be a good thing. Getting rid of highly radioactive waste, that's only got to be a positive.
This has been a momentous part of the programme and specifically for me, if I'm honest. Everything that we do, despite all the technical challenges and the complexity of being able to do high hazard risk reduction activities in a facility, the age that it is, 70 years old, is incredibly challenging. But that's made possible because of the people.